Hello friends, today we are going to learn the second chapter, that is second unit, wave motion. Now wave motion actually is the very basic concept and you have studied in a 11th or 12th standards. So what do you mean by wave? Suppose there is a pond and if pebble is dropped on the pond, then at the contact point of pebble and water surface creates a disturbance, and that disturbance goes creates waves which are on the water and the moves outward. These waves are moves outward from the creation point to the uh, expanding circle where it hits and up to the shore. So here there are two types of waves: mechanical waves and electromagnetic waves. Electromagnetic waves does not require any medium to propagate from the one point to another point. So but here we can have the types of waves. The electromagnetic waves, that you have a number of examples. We can see light waves, radio waves, television signals, x-rays, and all these things are electromagnetic waves. Now the types of waves. Types of waves. Here broadly, when wave motion is from disturbance actually that propagates to the medium by the repeated motion of particles in the medium without being or without or about there is a mean position. So according to the motion of particles in the medium, the waves are divided into two types. One first type is transverse waves, and second type is longitudinal waves. Longitudinal waves. So in a first, transverse waves. So if a particle of the medium vibrates in a vibrates about their mean position in the right angles to direction of propagation of wave. That is, if suppose this is the wave, then particles of the medium, they are vibrating at right angles to the propagation of wave, and therefore such waves are known as transverse waves. So simply, vibration of particles of medium in the direction at right angles to the propagation of a wave are known as transverse waves. Now electromagnetic waves are transverse waves. Now second type of wave, longitudinal waves. If suppose the particle of the medium, they are vibrating in a direction parallel to the direction of wave motion or propagation of motion of wave, then it is known as longitudinal waves. So longitudinal waves, uh, for example, string waves on a string, they are known as sound, or simply sound waves are longitudinal waves. Now there are number of waves in the world. So their properties we have to study. Now some characteristics of waves. First is wavelength. So this wavelength, suppose I will draw the wave, then I will have this is the wave, or so how much distance is wavelength? This is wavelength. This is the wavelength. So here in definition we can write wavelength is a shortest distance between adjacent crest or throws of transverse waves. So this part is crest and that part is throw. So it is a distance between two consecutive throws or crest. Wavelength is measured in a meter. Wavelength is measured in a meter. So in short, distance between two adjacent compressions or rarefactions. So compression and rarefaction, where compression means where the material particles they are gathered together, and rarefaction means they are separated by some distance. So like this. So these are the particles, but here this is the compression and rarefaction of the wave. So this is about the first characteristic. Second is amplitude. So once again I will draw the figure, and this is the wave. This distance is known as amplitude. So in short, distance distance of the particle of the medium from rest position or mean position. Here mean position up to mean position to top. This distance is known as the amplitude. We cannot say that it is a height. Sorry, you can say it is height of the crest or depth of throw, that is transverse wave, measure from the rest position. Measure from the rest position, and therefore this is the wave is increasing, and this distance is the amplitude of the wave. Now simply this distance is known as the amplitude of the wave. Now third part, frequency. Now in a frequency we can draw a figure to illustrate the frequency. So this much is the wave. So you can have this much is the wavelength. This is the one wave. This is one wave, and therefore we can draw some figures which we this is 1 hertz, this is say 1.5 hertz, and this is 3 hertz. So wavelength, and remember the number of vibrations produced by the vibrating body in a second is called the frequency. Means this is the wavelength. This is wavelength. Say wavelength. This is the wavelength. So after 1 second it will repeat, and therefore this is for second, therefore this is 1 hertz. This is the crest and crest part, and this is the throw. So again this in a 1 second these waves are more, and in a 1 second these are also more than those two, and therefore frequency is more here. That is 3 hertz frequency. This is 1.5 hertz frequency, and this is 1 hertz frequency. So this is as the this number is increasing, the number of crest or number of waves are more in a particular time. So when when one wave passes in the 1 second, then its frequency is 1, and therefore we can have waves per second, that is 1 hertz. So this is about the frequency of wave. Now speed of wave. So the distance which wave covers in a unit time is called speed. Within the unit time, how much distance is created by how much distance is covers in a unit time, this known as the speed of the wave. Speed actually measured in a meter per second. The sound waves travel in a different speeds in a different medium. So we can have, this is the definition of speed. Now traveling or progressive waves and its characteristic. Now what do you mean by progressive wave? Simply, when wave is traveling, is known as the we can have the progressive wave. So progressive wave, or we can say this is the traveling. Propagates itself in says this is the advancing the wave. Actually, wave motion propagates from one point to another point in the medium without being opposed by any boundary, known as progressive wave. That is, from one point to another point in the medium, if suppose there is no opposition of any boundary, then this is known as the progressive wave. There are some characteristics, they are very important as far as the concept is to be clear. First characteristic, the wave is produced by periodic vibrations, or we can have oscillations, periodic vibrations of the particle of the medium. That is, periodic means suppose this is the particle, this is going up to this, and within same time it will come down. So this is that is repetition against fixed time. So that is the vibration of the wave in the medium, vibration of the particles in the medium. Now each particle vibrates about its mean position with same amplitude and same period. That is, in a wave, in a progressive wave, each particle vibrates about its mean position. Suppose this is the mean position, it will go here and then down and again down. This distance is same, so this is mean position, this is extreme position, this is one of the extreme position. So each particle vibrates about its mean position with same amplitude and same period. So same amplitude and same period. So this type of wave is simple case is simple harmonic motion. Now third characteristic is that the medium does not move with the wave. This is very important. Medium does not move with the wave, whereas only energy can be transferred in a direction of propagation of the wave. Now this is very important. The medium does not move with the wave. For example, this is the pond and we disturb here by putting the pebble. Then what will happen? The water will move like this. The wave is moving like this, but water is not goes through this. So matter does not carry the wave, but energy will be carried. So in this way we can have this only energy can be transferred in the direction. For example, we in another way, if suppose uh, drum somebody beats drum here and sound will be heard at the very large distance, so there is no any transport of any matter, but it waves are moving or energy is moving up to that point. So this is another example. Now the phase difference between any two vibrating particles in the line of propagation is proportional to the distance between them. That is, phase difference between two vibrating particles in a line of propagation is proportional to the distance between them. Now, uh, last characteristic, the wave velocity is given uh, in a medium is constant and is determined by the density and elasticity. Density and elasticity. So in this way, these are some uh, characteristics of waves. Now in tomorrow's lecture, we will discuss the mathematical equation for progressive waves. Okay, thank you.